All right, so I'm getting off to a little late start this morning. Today, I'm going to continue on with the complex numbers. We also call them imaginary numbers. I just learned recently that is not a good name to use. I'll tell you more about that story in a little bit. But we're going to move forward today. We're going to talk about maybe some addition and subtraction of complex numbers and also multiplication. All right, so addition, subtraction, and multiplication of complex numbers. I'm going to start with one of the first patterns you're going to run across with when dealing with the variable I. All right, so we're going to look at one of the first patterns. So we're going to start with I to the first power. So I to the first power is what we call I. All right. Now, remember, the major key happens right here. That's what we talked about yesterday. Yesterday, when you raise I to the second power, what you get is a -1. All right. So I to the third power, if you take a look to what's happening right beforehand, I to the third power will be this one times this one, which gives us a -I. And now if we look at I to the fourth power, it'll be I to the second times I to the second, which gives us a +1. Now, once I jump to I to the fifth power, it brings me right back to here. All right. So there's a pattern that happens every 4 powers. It resets itself and then it goes right back through it. All right. So if you're up here, we're talking about the first power, 5th, 9th, 13th power. All of those will land on I. If we're talking about the these right here, I to the second power, we mean like I to the second, the 6th, the 10th, the 14th. All of those will land here. I to the third power, 7th, 11th, 15th. All of those will happen here. And then I to the fourth power, 8, 12, 16, so on and so forth. And it just keeps recycling its way back through this pattern. So if we're going to multiply these complex numbers together, I have 3 plus I times 4 minus I. The way that we do it is we start with the 3 and we multiply 3 times everything over here. All right, so that's what happens first. And if you follow the arrows, 3 times 4 is 12. That's why I start off with my 12 right here. And then if you follow the arrows again, 3 times -I is a -3I. So that takes care of the first portion of it. I'm just going to run the same thing. This time I'm going to start with I and I'm going to multiply I times everything over here. All right, now I times 4 is just 4I. But then you have a positive I times a -I. That's a -I to the second power. So what I basically did is something that you know as FOR method, first, outer, inner, last. That's basically what it is. I don't like to call it FOR method anymore. I just like to call it multiplying because that's all you're doing, multiplying. So I'm still putting emphasis on I to the second power. So I to the second power is equivalent to -1. If we're using multiplication, -1 has a meaning. In terms of multiplication, -1 means change sign. That's all -1 means when you're multiplying. All right. That's very important to understand. Is less house on your brain. -1 in terms of multiplication means to change the sign. All right, now back to the problem here. As you notice, I rewrote the problem. It's always good to let this coefficient show up until you really master that imaginary one that's sitting there. See, you don't see it here, but it is there. It's best to show it. All right. The more you get used to dealing with that invisible one makes everything easier down the line. So I'm going to go ahead and show it so that it makes sense with what I just said in the last slide. I squared basically means change the sign. So when I see this, when I see a -1 I squared, that really means +1. That means change the sign. That's what it means. The rest of the problem, I can bring that down. And from here on out, we go back into our regular algebra skills, combining like terms. So here I have a 12 plus a 1. That's 13. So I have 13 there. Then here I have a 4I minus a 3I, which leaves me with a +1I, also known as 13 plus I. All right, so this one is a special type of multiplication of complex numbers that I want to talk about. Now, we're going to follow the same process. All right, so I am going to multiply 5 times 5, and that gives me 25. I'm going to do that first. Next one, I'm going to multiply 5 times negative I, which is a negative 5I. All right. I don't like that 5. I don't like how that 5 looks. Negative 5I. I'm going to come here to the middle. I'm going to multiply 5 and I. That gives me a positive 5I. And then I'm going to multiply these right here at the end. And that's going to give me a negative I squared. Negative I squared. And remember, until we get used to it, I'm going to go ahead and stick that 1 right there. All right, so what happens here is this negative 5I cancels with the positive 5I. They are what we call inverses of each other under addition. So that crosses out to be 0. So what I'm left with is a 25. So I do have a 25 on the front. But remember, on the back, that means change the sign. So that's a +1. So my answer is 26. So the answer here is 26. This is something very, very special, and it's going to come up in the division of complex numbers. So I'm going to talk about this one for 1 second. When I multiply 5 plus I with 5 minus I, we call those conjugates. Conjugates basically mean they look exactly the same. The only thing different is the sign in the middle. They're opposites of each other. So if the middle sign on one is a plus and the middle sign on the other is a negative, but everything else is the same, they're conjugates of each other. The special thing that happens with conjugates and multiplication of complex numbers is every time you multiply conjugates together, you get a real number. All right, we get a number that lands on the number line. It doesn't have that imaginary part on it. It's not complex at all. It's just a regular number. So that's very, very, very important when we move forward, probably tomorrow when I talk about division of complex numbers. All right, so we have another problem up here. We have negative 7 plus 3I minus negative 10 plus 8I. So the main thing here is before. Remember, sometimes you got to sneak this little 1 right in here where you can see it. So I'm going to sneak it in right there. And then I'm going to put a box around this whole area because that's the only thing I want to make sure I get right at this moment. Remember what I said before. If I have a negative 1 being multiplied times anything, in terms of multiplication, negative 1 means change the signs. And it's literally that simple. That means what I'm looking at here is going to change on the signs. That's going to be a positive 10, so I write plus 10. That's going to be a negative 8I, so I write negative 8I. And so far, that part of the problem is handled. Now I can bring all these back down. I could bring the 3I down. And I could bring down the negative 7. And from here, we're just going to combine like terms. Numbers with numbers, complex with complex. For anyone that's just starting out in like algebra and you're getting to the area or the part of the subject where you have to combine like terms, use shapes, underline, circle, whatever you need to do so that you don't look at the wrong numbers at the wrong time. So this is something that I literally used to do when I was in the 8th and 9th grade. I used to make sure I put shapes around the numbers so that I don't focus on the numbers outside of them. So if I look only at my triangles, I have 10 minus 7, and that's an easy subtraction problem. That's 3. Now over here, now I might use a different shape here. So I might use circles there. So now I'm focusing on the circles. I have 3I minus 8I. So we know that 3 minus 8 is a negative 5. So what I have is a negative 5I. And what I've done was simplify my like terms. That's it. That's pretty much the quick things I wanted to talk about today. The multiplication, you know how to do multiplication. Plus, when you run across the conjugate version, right? When you do a conjugate, remember, you're going to get a real number every time. The addition and subtraction, I only did like one example on that because if you know how to combine like terms, which means basically you know how to put apples with apples and oranges with oranges. That is no different. All that stays the same. That transfers over and it behaves the same way as it did any other time. So I just wanted to make sure I did one of those. And also the patterns. When you're dealing with imaginary numbers, I to the first, second, third, fourth, fifth, sixth, seventh, eighth, there's a pattern involved, and it happens every 4 powers. All right, so those are the only ones I wanted to talk about. I do want to encourage you to look at my previous complex numbers upload. I have a link on YouTube to a whole series on complex numbers, and it's extremely interesting and mind-blowing, the story behind complex numbers and why they are important. So take a look at that. I'm going to try to put that same link in my video today. And it's 13 parts. I'm just going to put up the part 1. You can just start clicking through the rest of them.